Okay, so today is the day where we take all the stuff we've learned all chapter and put it together, because our goal here is to be able to solve equations. And then tomorrow we're going to take those equations and put them into real world situations where we have to apply them. So today is all about using your properties and the different things that we've learned about logarithms to be able to solve equations. Now, the main thing that we have done so far to be able to solve is to kind of use what I like to call that one-to-one property, where if you can get two bases, and this is talking about an exponential here, if you can get your bases to match, then you can forget about the bases and just work with the exponents. So in this case, I could write both of these with a base 7. So I'd call that one, I don't have to change the left, but this 49 I would call 7 squared to the 3x. And remember, a power raised to a power, you would multiply those. And now that I have the common base, I can just look at the only way these two are going to equal is if those exponents are equal. So then I just look at the exponent piece and go solve. All right, divide by 5. So I've got x equal to negative 2/5. Okay, that is still an option. So if I see something that jumps out at me that looks so obvious that these two could be written as the same base, this is my method. I'm going to go with it. But what happens when they don't match? Well, if they don't match, then you isolate that exponential expression. And so whatever the exponential is, if you've got some stuff added or subtracted off to the side, you kind of get that out of the way, you isolate it, and then the trick would be to switch forms. That's our go-to in this case. So let's practice the switching forms. So looking at this first one, this is the exponential piece right here. This 2 is in the way. Let's get it over to the other side. So if I subtract 2, I now have this. Now this is not 2. I'm not taking 3 times 2 here to get 6. It's not that. 3 to some power is going to be a 6. Well, 3 to the first is 3, and 3 to the second is 9. It's somewhere in between. What I'm going to do is switch this to a logarithm. So it's going to be log base 3 of 6 equals my exponent. All right, and now I go to my calculator. So it's a base 3, so I'm going to have to do that change of base thing. So do math, alpha math. It's a base 3 of 6. And we get, and I'm going to round to 2 decimal places today. If you do not have your calculator, you need to stop this video and go grab it. Okay, next one. The exponential piece is all of this. This plus 2 is not like out to the side like it was here. This is part of the exponent. So I'm going to jump right into switching forms. So this is going to be a log base 5 of 12 is equal to the exponent. Now I'm going to see what I need to do here. Well, I look at this. This is just something I would type in my calculator right there, and then subtract 2, and I will have solved for x. So let's give it a shot. Math alpha math. Okay, so I got the 1.54, and I just subtract 2 from that. And so then my answer is negative 0.46. Okay, let's try one more. All right, it looks like this is all part of the exponential here, but really it's just e as the base. The 5 is just getting multiplied. So I do want to get rid of that 5 first. I'm going to divide both sides by 5. Now, it's a base e, so if I want to switch forms, that means switching it to a natural log of 40 equals my exponent. So then I'll come back and I'll divide by 4. All right, so in my calculator, natural log, which is next to the 4, of 40, take that answer, divide by 4. And x is 0.92. All right, easy enough, but I am going to start, getting a little bit more going on with these equations, a few more steps involved than what this is. Before we jump into harder ones, though, let's go ahead and talk about logarithms. What if I give you a logarithmic equation? How do we solve that? Well, kind of like before, I'm going to try to get the logarithm isolated, and then I am going to switch forms. This time I'm going to switch it to an exponential. If I can switch it to an exponential, then I can ideally be able to solve it. So in this example here, this is just basic and simple. There's nothing going on except the log. Just switch forms. It's just a 2 to the 5th is equal to the x. Okay, so x is 32. Now, of course, I'm going to make you do a little bit of work to isolate that logarithm. So in this first example A, you can see the 7 out in front. So the first thing you should be doing is dividing by that 7. Now, this is a natural log, so remember that this is assumed to have a little e right here. So when I do my loop to switch forms, it's e to the 4th is equal to x. I am going to want, I lied. It says leave answers exact. I am not going to round that. I am going to leave it e to the 4th. I'm probably doing that because in my math lab, they probably say the same thing. If they don't tell you what to round your answer to, it means they don't want you to be giving them some random decimal value. They want you to leave it exact, which might mean leaving it e to the 4th power. Okay, next one. Lot going on, but the argument of the logarithm is all of this. This 19 is not fair game to get rid of. It's part of the logarithm. So I'm going to switch forms. 2 to the 3rd equals that. Now that I've gotten rid of the logarithm, yes, that 19 is fair game to get rid of. I'm going to take it over to this side. 2 to the 3rd is 8, plus 19 is 27. Last step, let's cube root both sides. I got lucky here. That's not always going to play out to where it's a perfect cube root, but it is today. There we go. Okay, last one here. This is the logarithm. So I have some stuff over here I could be rid of. I want to move this 4 over to this side. So I'm going to subtract the 4, but I also see that there's like a negative in front of that. So when I subtract the 4, this is really what it's going to look like. So I want to get rid of that negative. So I'm dividing both sides by a -1. And then I'm ready to switch forms. All right, 4 to the 3rd is equal to x minus 2. 4 to the 3rd power, no calculator. What is it? 4 to the 3rd, 4 to the 3rd, 64. Now add the 2. All right, this page is kind of glitchy. Couldn't figure out, it was just quicker just to rewrite it all than to troubleshoot why only half of it showed up. So here we go. On this, hopefully you have the notes anyway. So the previous slide, I was solving log equations that just had a single log. So what happens when you have the log in that equation multiple times? All right, we have some strategies to look at. One of them, the easiest scenario, would be if you just have one log equal to another log. That's what we have called that 1-to-1. That's what we did the other day. If you can get one log equals another log, you just drop the logs, okay? So in this case, if I just forget the logs, the only way these two sides of the equation are going to be equal to each other, this is what we'd call a 1-to-1 property with the logs instead of the exponentials. You're going to end up with an x plus 4 equals a 4x. And then you solve that to figure out what would the x have to be so that both sides ended up being the same thing. And that's what I get right there. X would have to be 4/3. Okay, now perhaps another strategy would be that you have to use your condensing, expanding properties that we talked about. Use those properties until you can get it to have one log equals another log. Now, what's tempting, though, is if you'll look at my example here, that I have multiple logs. This is not a log equals log. I have subtraction here. So the number one rule, you cannot just go start slashing the logs. You cannot do that. You only get to slash the logs if you're doing it when you have a single log equals a single log. So what I'm going to do is use my properties to condense this into a single log. So subtraction tells me that I need to divide. So I'm going to condense this to the log of, and I'd have an x plus 6 divided by an x plus 2 equals log of x. All right, so now I have log equals log. Now I get to drop the logs, and I get x plus 6 over x plus 2 equals x. I didn't give myself much space to work, so I'm going to come up here. Now, I don't love the fraction, so the first thing I'm going to do is multiply both sides of this equation times that x plus 2. It'll cross off on the left, and it just looks like this on the right. All right, let's go ahead and distribute. Now this is different. All right, now I'm ending up with a quadratic. So on quadratics, I want to set them equal to 0. So I'm going to bring everything over here to the right side, subtract that x, subtract that 6, and I'm going to factor. Wrong factors. Factors of 6. Oh, that have a difference of 1. No, that was good. I just wasn't thinking there. So I want to end up with a positive 3 and a negative 2. All right, so x is equal to 2 or negative 3. Now, this is the first time we've come across this, and we have to talk about something here. Everything I did was algebraically fine there, but do you remember that rule we talked about a while back that you cannot take the log of a negative number? And so when I ended up with a negative 3, that makes me a little bit nervous. But to be honest, it's not just the negative 3. Pretty much in any log equation, you need to go checking those answers to make sure that what you plug in will not turn your argument negative. So like right there, I can't plug a negative 3 in. That's not going to work. A 2 would be fine. A 2 would be fine here, and a 2 would be fine here. But think about if that was a minus sign and I put a 2 there. Would that work? No, because then I'd end up with a negative 4 for the argument, and that is not allowed. So always check your answers on these logarithms. I'm going to x out the negative 3, so my final answer just x is equal to 2. Okay, the third scenario that might play out is you might have to do some properties, do some condensing, and then instead of it a log equaling a log, it might be a log is equal to a number. Like look at this example I have over here. I have 2 logs on the left. I'm going to go ahead and condense these. I went ahead and tried a natural log so we could practice that. So it's going to be the natural log of x plus the natural log of 2. Remember that addition can turn into multiplication. So I'm going to change it to this. All right, and then it equals 3. This is not a scenario where I'm going to slash the logs because I don't have a log on the right side. This is a switch forms. Okay, so that's a switch forms. I should have probably added that in over here. That's your strategy, switch forms. So this is going to be an e raised to the third equals 2x. Divide both sides by 2. And now this is a calculator problem. You're going to do your second ln to get that e with the power. And then take your answer there and divide it by 2. So x is 10.04. That's going to be fine to be in the checking in those 2 logarithms that are in this original equation. Oh, sorry, that 0 didn't show. 10.04. Okay, so now what I'd like you to do is practice all of those strategies. And just for practice, I'm changing the directions. I think it's always good that you read the directions because it does definitely change on what we should be rounding to. So you're going to solve. If you were in class, you'd have a buddy and you'd be working through these problems with a buddy. You're not. So you get to do them by yourself. And it says find exact answers and then take your decimal and round it to 3 places as needed. So keep it exact all the way through until the very end, and then you can round to 3 decimal places. So what you need to do now is pause this video and see what you can do with these 5 problems. Come back when you have them done. All right, here are my 5 answers. Go ahead and check your 5 answers. If you agree, let's keep moving. If not, pause the video and figure out where you might have gone wrong. Okay, so once you have those 5, I'm throwing 4 more at you, a little bit harder. Go ahead and pause the video and try these 4 on your own. Okay, here's your answer key. Just a few things to note. I don't really care if it's a decimal or a fraction. Just pay attention to the directions. Down here, I kind of purposely, when I did this in my calculator, of course it didn't come out nice, but I only wrote 1.8, but I always leave the full value. So when I subtracted 5, I subtracted it from the full value that was in my calculator. So it's okay here as long as you're keeping the full value in your computation so that at the very end, we all have the exact same answer. Okay, if you got these all right, let's keep moving. Now, these are some trickier problems, some weird things kind of going on. So I wanted to go over a few things that look scary when you first look at them, but it's very doable. Looking at this first example, we've got some weird things going on here. You have e raised to a power times another e raised to a power equals 3e. Okay, you got a lot of e's going on here. But this is not something where you cancel all the e's out. The hint here is to use your exponent properties. So don't get caught up in that it's an e. You are multiplying two values. They have the same base. This would almost be like if you had an x to the 7th times an x to the 2nd. You would just have an x to the 9th. You just add exponents when you have a common base. So that's what I'm going to do. I'm going to write this e to the, and then I'm going to add these exponents together. So this 2x and negative 4x would get me a negative 2x plus 1 equals 3e. And now what I have is this e just sitting here once. It's an exponential. I'm going to switch this to a logarithm. Since it's a base e, I'll be using a natural logarithm. So it's the natural log, remember that's your base, of 3e equals your exponent. So I'm going to type this. Now remember that e is not a variable, that's actually just a number. So I'm just going to type it as is, natural log 3, and then I do second natural log. So e, oh, that's kind of tricky. Okay, I don't really need a power on this e, do I? So I'm just going to put a 1 there for that power. Okay, so I have that number. That's a 2.09 or 2.10 is what that would round to. But I'm not done, so I'm just going to subtract 1 from that. And then I'm going to divide by negative 2. And then my final answer is going to be a negative 0.549 is what that would round to. Okay, here's another one. It's different though. It's e to a power and e to the power, but this time we are subtracting instead of multiplying. That actually makes it a little bit harder. And this one you for sure probably don't notice it so much, but what you have is like this e to the x. But this is an e to the x that's ultimately being squared, because it would look like this, e to the x squared. That would be an e to the 2x. That's what's happening. So this is like a linear term. Here in the middle, this is a square term, and there's your constant. This is a factoring problem. So let's try factoring. Okay, the easy part is probably the 3 and the 1. And the signs are the same. They're both minuses. That's the easy part. Now, what do you put in here? Well, it's just an e to the x times an e to the x, because that's an e to the x squared, which would be e to the 2x. That's where I'm getting right there. And look at your outer. That's negative 3 e to the x, negative 1 e to the x. It's a negative 4 e to the x. Now you set them each equal to 0. So e to the x minus 1 equals 0, so it equals 1. And now I would have to switch forms. This is natural log of 1 equals x. Oh man, I bet you could do that in your head. What is the natural log of 1? E to what power is 1? 0. Okay, next one, when I said this one equal to 0, it's going to be the e to the x equals 3. Now this is not quite as nice, so natural log of 3 is equal to x, and that one I'll go to my calculator on. And I have 1.099. So these are your two solutions. Okay, the last one here, this is an exponential. And this is weird, it's an exponential equals another exponential. Okay, so what we could do, in the same way that you could square both sides or take both sides times 7, you could also take the log of both sides. By taking the log of both sides, what I would then do is use my log property. Anytime you have an exponent here, you pull it out in front. Take the exponent, pull it out in front. So now what I have is 2x minus 1 times the log of 3. And over here, I have x plus 2 times the log of 0.4. Now the log of 3 and the log of 0.4 are just numbers that I will then distribute through. So let's see what the log of 3 is. So I have a 0.477, but it's going to get distributed, so that is times 2. I get 0.954x minus, when I take it times the 1, it's just that 0.477 equals, okay, now I'm going to do it on this side. I'm going to take the log of 0.4 and distribute it. So this is going to be negative 0.398x, and then I'm going to take it times 2 to distribute it to the 2. So that's going to turn into a minus 0.796. Now I'm going to get the x's on one side, the numbers on the other. But you've got to be careful because you've got to keep those full values the whole way. So you're going to have to go up and do some grabbing. All right, first thing I'm going to do is I'm going to add this 0.398 number over here. So I'm going to grab the 0.954 number, and I'm actually going to do a minus and then go grab, no, I'm not. Yes, I am. Grab it because it's a negative. So I'm going to end up with a subtract the negative, which is what's going to be my addition there. So just some calculator strategies there. 1.352x. Now I'm going to move my numbers to the right side. So I'm going to go grab the negative 0.795 number, and I'm going to then take this, and I'm going to end up having to go up and grab that 0.477. Now, in this case, it was already positive, so I don't have to worry about doing the minus and negative on this. Negative 0.319. Last step is to divide. Go grab the full value of this to divide. X is equal to negative 0.236. Okay, so these last couple slides are definitely some doozies, so don't be afraid to watch those again. Make sure you have some good notes on them because you'll want them during the homework. All right, hope this helps. Good luck.